Okay. Good morning to one and all. So the screen is visible. Anyone, can you please reply? Screen is visible.
Yes, sir. Yes, sir.
So we have started already the instrument transformers. We have started. I told that one for the measurement circuit, we are going to for the measuring the electrical voltage, current, energy, power, and all the things. So the instrument transformers are used to with some protective relays and all the things we are going to consider, because whatever the high level voltage range is there, high level voltage and currents are reduced into low level for the measurement here. Now for the measurement we are going to consider high level to the low current, higher voltage to the lower voltage, higher current to the lower current. We are going to use that one example. The current we can bring that one into up to 5 ampere, 1 ampere also. The whatever the 220 kV, 400 kV voltages, we are going to bring up to nearer to the 110 volts. 110 volts will bring that one. So the instrument transformers are mainly classified into two types. The instrument transformers are mainly classified into two types. The yesterday class only I told those are current transformers and potential transformers. What is happening here? Some people they are joining now. Again and again they are back now. Okay. So current transformers and potential transformers, whatever the high voltage current is there, that one we are going to bring into low voltage current. The potential transformers, it is going to bring the higher voltage to the lower voltage, it is going to bring that. So these two types are there. One by one we are going to discuss. Before that, the ratios are there. Some ratios we have to discuss about the instrument transformers. So that ratios for the current transformer is different, potential transformer is different here. So only definitions are the ratios of instrument transformers. So the first one will come, that one. All of you know the transformer ratio. In a single phase transformer you have studied in the first year. In that one, the N1, N2 by N1 equal to E2 by E1, V2 by V1 equal to I1 by I2. Like that you have studied. So based on that, here the transformation ratio we are going to consider. The transformation ratio is the magnitude of the primary phasor to the secondary phasor. Primary phasor to the secondary phasor. So whatever the voltage is there, suppose we are going to consider the primary voltage. Two windings are there. So number 13. Primary voltage to the secondary voltage for the potential transformer. For the current transformer, primary current to the secondary current. The current transformer is there means it is going to step down the current from higher current to the lower current. Potential transformer is from higher voltage to the lower voltage. What is the magnitude, the phasor they are using here? Now the magnitude of primary phasor is nothing but primary current transformer ko primary current kitna hai, in the primary winding how much current is there, and in the secondary winding how much current is there. That ratio it is going to give the transformation ratio here. Now the transformation ratio is the magnitude of primary phasor to the secondary phasor. This is common definition for the instrument transformation. Common definition, it may be CT or it may be PT, potential transformer. But when you will consider for the transformation ratio for the current transformer, on that condition it is the ratio of primary current to the secondary current. And for the potential transformers, you can say that one, it is the ratio of magnitude of primary voltage to the secondary voltage. So that is the ratio of transformation ratio we have discussed here. Now that is called transformation ratio, we are going to call that one. Is recording or not? Okay, recording. So next ratio is, that is called nominal ratio, we are going to consider here now. It is the ratio of rated primary current or voltage to the rated secondary current or voltage here now. The rated value here now, from the for the primary winding how much current it can take, for the secondary winding how much current it can take, like that. Based on that we are going to discuss. So the nominal ratio is the primary winding how much rated current, what is the rated current of primary winding, what is the rated current of secondary winding. Based on that the nominal ratio is depends here now. So the nominal ratio is the rated primary current. For the current transformer we are going to define the, it is the ratio of, nominal ratio of current transformer is the ratio of primary rated current to the secondary rated current here. That is called nominal ratio of CT, we are going to call that one. For the similarly, we can tell that one for the potential transformers, it is the ratio of rated primary voltage to the rated secondary voltage here. For the current transformer, rated current of primary to the rated secondary current. For the voltage potential transformer, rated primary voltage to the rated secondary voltage. So this is the nominal ratio definition. Next, turn ratio will come here. Now turns means number of turns in the primary, number of turns in the secondary, we know that one. Already in the transformer, you have studied the transformer. Okay, for the CT it is, suppose I1 by I2 equal to I2 N2 by N1, like that it was there. So if it is I2 by I1, then it is N1 by N2, like that. The turns ratio for the CT you consider, turns ratio is for the CT is, it is the ratio of number of turns of secondary winding to the number of turns of primary winding, we are going to call that one. That is called for the CT. For the PT, number of turns of primary winding to the number of turns of secondary winding. See, it is up to nominal ratio, it was same only, primary to secondary, primary to secondary. But here for the turn ratio, for the CT, it is secondary winding to the primary winding is there. For the PT, primary winding to the secondary winding is there. So these are the three ratios you have to remember, that is transformation ratio, nominal ratio and turns ratio. Will you remember these definitions? Yes? I'm asking to you only.
Yes, sir.
Can you anyone tell me what do you mean by transformation ratio of for CT? Transformation ratio for CT, current transformer. Just now we have discussed it. The answer is we will tell 0 here now. That is the problem for the online session. Whenever I will ask any doubts, understood, yes, you will tell. But why you are not going to try to give the answers? The magnitude, I told that one, magnitude of the primary phasor to the secondary phasor, general. For the CT, the magnitude of primary current to the secondary current. Magnitude of primary voltage to the secondary voltage, that is called PT, potential transformer. Same, instead of magnitude, we are going to use rated for the nominal ratio. But for the turns ratio of CT and PT, for the CT, it is secondary number of turns to the primary number of turns. For the PT, that is primary to the secondary again here. Only for the CT, it is changed, that is only turns ratio. All other things are same. So these are the three ratios we have discussed for both CT and PT. Next, what we will do, we'll discuss about only current transformer. What do you mean by current transformer? How it is going to operate? What are the different types are there? How we are going to draw the phasor diagram? Everything we are going to discuss here. So just see here, in a three-phase line, R, Y, B, three lines are there here. Three lines are there here. So the primary is itself, it is a power conductor. The power conductor we are going to use as here only, which is we are going to connect the primary winding of the current transformer. We are going to connect in series with the power conductor here. Either power conductor है, ये winding इधर ही connection हो गए series में. Yes.
Yes, sir.
The power conductor, the primary winding of the current transformer is connected in series with the power conductor only directly here. So this is primary winding we are going to call it, primary winding. Next, the secondary winding we have taken here. The secondary winding we have taken here, and we have connected one switch for connecting and disconnecting the emitter in the circuit here. We have connected one switch for the connecting and disconnecting the emitter in the circuit here. Now, suppose we want to measure the current here now by stepping down that one 0 to 5 ampere here. Now the switch will be open. If the switch will be open, no current will flow here. All the current will flow through the meter and it will go back here to that one. Yes, it is to the closer path here. If we don't want to connect the emitter in the circuit, and that situation, what we have to do, we have just close this switch. By closing this one, there is no, it will act as a short circuit. All the current will flow like this one in this circle. We have connected one ground connection also. The secondary is also connected to the ground connection. If higher voltages are there, if lightning will occur over there, then it is going to bypass this one into ground here. It is going to bypass that one to the ground here. Now excess voltage or current is there. It is sending to the ground connection. The three-phase supply we have used here now. In that one phase, we are consider the primary of the current transformer is connected in series with the power conductor itself, and the secondary is connected to the emitter, and in between we have provided one switch here now for the connecting and disconnecting the emitter. If we want to connect the emitter, then we have to open this switch. If the switch is open, then current will flow here, and if we close the switch, then we can disconnect this emitter. To disconnect the emitter, we have to close the switch here. If the switch is closed, all the current will flow in this cycle. So this is the working principle of the current transformer here. No? Working principle of the current transformer. A current transformer is a device that is used for the transformation of current from a higher value into a proportionate current to the lower value. From the 20 ampere to the 5 ampere it is going to bring. So higher current to the lower current here. It transforms the high voltage current into the low voltage current, due to which the heavy current flows through the transmission line is safely monitored and by the emitter. We have to, whatever the heavy current is there, that one safely we can monitor by using the current transformer here. See, actual construction they are telling here now. The primary and secondary windings are insulated from force and each other. We have used insulated windings. We are going to use that one. It is connected in series with the line, means it is also insulated, that one here. Primary, each turns are insulated here. Now, the primary winding is a single turn winding, also called as bar primary also. Directly, whatever this winding is there, instead of this one, we can connect this one. We can use that one as a bar type. Directly from the connector only, we can consider as primary. We can secondary, we have to connect near to that one. So that is directly connected, are also called as bar primary, and carries the full load current. It is going to carry the full load current over there. So the secondary winding of the transformer has a large number of turns here. If the number of turns are more, then we can reduce the current over there. So secondary winding of transformer has large number of turns here. Now, the primary is connected in series with the power circuit. Just now I told in series with the power conductor or power circuit here. Now, therefore, sometimes it is also called as series transformer. The current transformer is also called as series transformer. We are going to call that one here. Secondary is connected directly to an emitter, as the emitter is having very small resistance here. The resistance of the emitter is very small. Hence, a secondary of current transformer operates almost in short circuited condition only. In a short circuit condition only, it is going to offer. One terminal of secondary is earthed to avoid the large voltage on the secondary with respect to earth here. So with respect to earth, if the voltage is large on that, to bypass that one, we have used one terminal of the secondaries. We are going to connect to the earth over there here now, which in turns reduce the chances of insulation breakdown. Because of heavy voltage, what will happen? I think in a rainy season you have experienced that one, lightning strike हो गए तो थोड़ा TV वगैरह पहले burn हो जाता था. That is called because of the heavy voltage only. It will insulation breakdown होके short circuit. After short circuit, it is going to leakage the temperature and current. It is going to show. Also protect the operator against high voltage. It is going to protect the operator also. Moreover, before disconnecting the emitter, secondary is short circuited through a switch over there. We want to disconnect the emitter, then this secondary we have to short circuit here. By short circuiting this one, all the currents we are bypassing here only. It will no current will flow through the emitter here now. Before disconnecting the emitter, secondary is short circuited through a switch as shown in the figure above to avoid the high voltage buildup across the secondary here now. To avoid the high voltage across the secondary over there. So this is the working of the current transformer, how it is going to operate this one. Any doubts here? Any doubts? Any doubts?
No, sir.
Okay. Next, we will go for the current transformers. It has some different types are there, but according to your textbook, they have mentioned mainly the current transformers are classified into three types here. One is wound current transformer. Second one is toroidal current transformer, and third one is bar type transformer here. So wound type, bar type, and toroidal based on the safe only they have derived here now. Wound means when primary winding and secondary winding wounded over there, and toroidal means in the safe of toroid it is there. Bar type means we are going to use the primary as a bar here. That's so same, the name itself it is indicating that one. There are the current transformers are classified into three types here now. One by one we will discuss here now. See here, this is the current transformer, wound type current transformer we are using here now. So the upper circuit it is here. The primary winding we have provided two terminals, and secondary winding we have provided two terminals here now. In the magnetic core we have used where we are going to connect the conductor here now. In this transformer, the primary winding is compressed inside the transformer here. The primary winding is inside, it is there, and the primary winding had a single turn and connected in series with the conductor, that is measured the current here now. Only one conductor we are using here now. Inside that primary we have provided two terminals to connect in the power line here now, one and another one here now. The current will flow like this here. So conductor, that is measured the current here. The wound transformer is mainly used for measuring the current from 1 ampere to the 100 amperes. See here, this one we are going to use for the 1 ampere to the 100 amperes here. Now see one, this is the primary is there, primary winding, इसके ऊपर हमने secondary winding ऐसा paste कर रहे हैं, secondary winding ऐसा we are going to hold that one here. So two terminals we have provided for the secondary winding, two terminals we have provided for the primary winding. From the secondary winding we can connect the emitter here now. So the higher ampere we have reduced into the lower ampere, lower current we have reduced. That is called wound type transformer we are going to call here. Next one, bar type transformer is there. See here, the power conductor itself we are considering as a bar here. No, one rod we are using. In that rod we have used the current transformer and secondary winding is connected here. On the rod only the current transformer is mounted here, and with the for the secondary we have connected the emitter here. That is called bar is there here. No, bar type transformer we are going to call here. The bar type transformer has only secondary windings. इसको secondary windings ही रहते, primary winding नहीं रहते. That same bar we are going to use as a primary winding here. Now the conductor on which the transformer is mounted, किधर हमने CT we are going to fix that one. That conductor itself it acts as a primary winding here now. That is called bar type current transformer. Toroidal transformer is also same like this one only, but it doesn't contain any primary winding. इसको अंदर कुछ primary winding नहीं रहते, but whatever the line is there, the transmission line or power line is there through which current will flow, that one we are going to attach to a hole inside that toroid. We are going to attach to that conductor here. Now it acts as a primary here now. So this transformer does not contain primary winding. The line through which the current flows in the network is attached through the hole or window of a transformer. That is called primary here now. So the major advantage of this transformer is that transformer has symmetrical shape, due to which it has low leakage flux, thus less electromagnetic interference is there. I think you may heard that one, some clips are there like that, clamp type current transformers are there now. हम किधर भी एक लाइन को कनेक्शन करना है ना, ऐसा मोबाइल पे एक रहते, एक क्लैंप रहते, just we have to open this one and we have to hold the conductor here. It act as a secondary winding रहते, इसको hold किया ना, it will act as a, the conductor act as a primary, and the secondary winding the current will flow over there. Clamp type current transformers are also there, that is toroidal we are going to call that one. So these three types of current transformers are there, that is wound type, bar type and toroidal type current transformers are there. So the theory part for the all current transformer, any current transformer you consider that one we are going to discuss here now. First we have to know what is the turn ratio for the current transformer. Anyone can you tell? Turns ratio. Definition, turns ratio. Turns ratio.
2 divided by N1.
Huh? Yes. I am asking the turns ratio.
Number of turns of primary upon secondary.
No. For the current transformer, it is secondary to the
Primary winding.
primary. For the CT, it is secondary to the primary. For the PT, it is primary to secondary. Okay. So that one only. I am going to show the one phasor diagram here now and one circuit diagram based on that. So first we know the turns ratio is number of secondary winding to the turns to the number of primary winding turns here now. We are going to use that RS is there in the circuit diagram. I will show this circuit diagram here now. See here, the equivalent circuit diagram of the current transformer we are using here now. So that is RP, the resistance of primary winding, inductance of the that is reactance of the primary winding we are going to use. Whatever the connecting leads, whatever the connectors are there that has some resistances, for that reason that is called RE we have used, the burden we are going to call, and emitter we are going to use, that is called IM, the current flowing through that emitter IM, and current flowing through the external resistance that is called IE, and the summation of these two is nothing but I0 here now. Okay, so here the primary winding and secondary winding is there. The flux is nothing but that is phi, which is linked to the both primary and secondary winding here. No, so because of the primary current, the number of turns connected to the secondary current EMF will induces in the secondary winding. That EMF induced, it is nothing but it will produces the current here. No, that is IS we have used here. No, so RS is the resistance of secondary winding, XS is the reactance of the secondary winding here. No, some connecting leads and connecting leads are meter reactance we are going to consider here. So the EMF induced in the primary is EP, EMF induced in the secondary, that is called ES here. No, same thing we have written here. No, RS is the resistance of secondary winding, XS is the reactance of secondary winding, RE is the resistance of external burden or external meter resistances, current coil, or including leads we are going to call that one. And X is the reactance of external burden or reactance of meters we are going to call. EP is primary induced voltage, ES is secondary induced voltage, NP is number of primary turns, NS is number of secondary turns, and VS is the voltage at secondary winding terminal, IS is the current, secondary winding current here. No, phi is the working flux. All the things we have written here. No, the angle is angle between secondary induced voltage to the secondary current here. No, voltage and current here. No, and I naught is exciting current, IM is the magnetizing current of the meter, I naught is the loss component, I, that is I is the loss component of exciting current here. Now, so these all parameters we have derived here. Now based on that, according to this circuit diagram, we have taken this all the parameters here. So next what we have to do, we have to draw the phasor diagram here. Now we have to draw the phasor diagram. See here the IP is there. IP is the equal to I naught and how some current will flow through the this one primary winding here now, which is linking with the turns ratio, and because of the primary current only the secondary current is producing here. Yes, we are giving the supply to the primary only, but secondary winding the EMF will inducing here now. So because of IP only the current, secondary current is producing here now. So IP is the summation of this I naught and IS here now. NIS, the turns ratio into secondary current we are going to consider here now. So we'll start from here only. First we'll take IE and IM. I will take the x-axis reference, that is called flux. I will take here now. The magnetic flux I will take as a reference here now. I'll keep this one here now. This is flux I have taken here now. Magnetic flux I will take that one. See here, I naught is the summation of IM and IE. Yes or no? Here the magnetizing flux which is in phase, the whatever the meter current is there, it is in phase with the flux here now. For that reason I will consider here now, that is IM here. IM I will consider here. Next, see here, it is a inductance is there, it is a resistance is there. So inductance current, that is leads the resistance current by 90 degree. Almost we know that one. So for that reason the 90 degree, so inductance current is lagging, resistance current is leading here. 90 degree is there. Yes, here coil is there, here resistance is there. Both should 90 degree difference is there, the phase difference of these two current. Yes or no?
Yes, sir.
So suppose I will take the reference as current flowing through the resistance, means the current flowing through the inductance should have 90 degree difference is there here now. 90 degree it should have to lag here now. Based on that one only we have considered here. Here IM we have considered, IM ko IE it is leading because it is resistive load is there. Here it is inductive load is there. So this is 90 degree difference is there. But summation of these two, what it is going to give? I naught equal to IE plus IM. We can tell like that. This I naught is equal to IE plus IM. Up to here it will come. Some current will flow here. Some current will flow here. Again both will join. And here what you will get? I naught only. I naught equal to IE plus IM. Yes. The formula.
Yes, sir.
So
Yes, sir.
what we will do, this magnitude we will take here now, and this magnitude we are going to join here now. The I naught value we are going to get here now at the center. Whatever the difference is there, angle difference, that one we are going to consider here as alpha here now. The I naught current which is leads the flux producer, that is phi, by an angle of alpha. We can consider that. This is one part here now. This part is over. This part is over. Next, what we have to do, we have to identify the primary current here. The primary current we have to try. Primary current is related to the I naught. It is the summation of up to here primary current is there. Here, which current is flowing here? Just a minute, I will clear all the things. I will tell that one. Here IP is there. Up to this point, IP will come here now. So IP is the summation of I naught here now. I naught is there here. It will flow some current here now, and some current will flow here. Because of this current, what will happen here now? The EMF induces in the secondary. Here, the number of turns or turns ratio, the product of turns ratio, and here IS, it is nothing but it is also some current here. So IP equal to, we can say that I naught plus NIS, we can call that one here. IP equal to I naught plus NIS here. The number of turns linked with the secondary winding, and that is called secondary current. We are going to call that one. So we will draw like this. So based on this equation, we have to draw here now. Here IP I naught is there. I naught I will take here now up, and NIS I will take that one here now. NIS, that is called, again it is comparing that one here now. It has some angle theta here now, deflection here now. So that NIS I will draw here. NIS. That NIS, summation of NIS and I naught, it is going to give the IP value. It is going to give the IP value here. So that angle, see here now, that angle we are going to give here now. So the NIS we have considered, whatever this IE external current to the NIS, that is called delta here now, and IP and NIS, that is called theta here now. Theta we are going to consider, that is primary to the secondary here, the angle difference between primary to the secondary. So can anyone tell me what is the angle difference between this total now? What is the angle this one here now? How much is there total? It is from here to here.
90.
Huh?
90.
This is 90 degree. Okay, 90 I will write here now. 90 degree. Minus this part we have to minus here now. इधर तक ही चाहिए ना हमको, ये पार्ट माइनस करने का, माइनस अल्फा वी कैन राइट हियर नाउ. देन इधर तक चाहिए ये पार्ट माइनस करने का, माइनस डेल्टा, वी कैन राइट लाइक दिस.
Yes, sir.
90 minus alpha minus delta, we can write like this. See here, this is the phasor diagram is over actually, but to derive the equations or derivations, what we have to do? See here, the angle alpha here, I naught is there, same angle is there here. This one it is moving here now. दोनों parallel line हो गए ना ये same. This one and this one. Yes. See here, line देखो आप, angles देखो, angles are same only, this one and this one here. Yes. I naught and here A to IP here. Both the angles are same only. Yes or no? The mirror copy you can take this one. This mirror copy is there. This one mirror copy you send into here means it will give the same, the triangle we are going to give here now. Same triangle it is going to give here now. This one is I naught here now. Here we are going to consider as IM. Actually it will come like this here. 90 degree it should have to come. Like this it should have to come. But in the book they have given like this here. This is 90 degree here. So this terminal I have given as A. This terminal I have given as B. This terminal I have given as C here. Based on this triangle, we are going to derive the equation for the, that is ratio equation here. Transformation ratio equation, phase angle, we are going to derive here. See here, this is OA, OA equal to NIS. Okay, AB, AC equal to I naught, AC equal to I naught, and BC equal to I naught sine 90 minus alpha minus delta, and AB equal to cos 90 minus alpha minus delta here. This angle is there, same angle, the reflected copy we have used here now, that is here. Based on this phasor diagram, we have written some equations here. Now we can check those equations in this diagram here. See here. So the angle here, angle between BAC here now. BAC is 90 minus alpha minus delta here. BAC, angle of BAC is 90 minus alpha minus delta here. We have considered here. No. What is the value of AC here? No? A to C, what we have considered? A to C. I'm asking to you peoples only. A to C, what is there here?
I know.
Is it audible? Is it audible?
Yes, sir.
इंटरनेट का इशू है थोड़ा, ठीक है, इधर सर्कल आ रहा है उसके लिए, ठीक है. Here A to C we have considered that as I naught here. Total A to C, that is called I naught, we have considered here. No, so AC I have written as I naught here. No, and O to A, OA is nothing but here O is there, here A is there. What is this value O to A? That is called NIS. NIS we have considered here. No, and OC is also important here. O to C, here O is there, here C is there. What is the output here now? O to C. Which current we have used?
IP.
IP. Very good. That one, these are simple we have considered here now. But we have to identify BC and AB here now. Here I naught is there. I naught is there. While writing that one adjacent, opposite, hypotenuse and all the things, BC equal to I naught sine theta. If it is theta is nothing but BC equal to this one, I naught sine theta, and AB equal to I naught cos theta. Is a likhte na triangle circuits. So like that, this BC equal to I naught into sine of 90 minus alpha minus theta here. 90 minus alpha minus delta. Okay. BC we have considered. Similarly, for the AB or BA, that is called I naught cos 90 minus delta minus alpha here. We have considered. So this minus delta and minus alpha. See, up to here, this equation is clear. ये इक्वेशन क्लियर होने के बाद मैं आगे प्रोसीड करता हूं. This equation is clear. See, any triangle you consider here now, this triangle you are going to consider. Okay, this is the angle we are going to consider. This is A. Okay, this one is B, 90 degree, and this is C here now. So A to C we are going to consider this one as I naught here. I naught we are going to consider here. So one term we can consider this one as AB is I naught cos delta, and this angle we will consider as theta here now. I naught cos theta and I naught sin theta. A diagram study kiya. In the first year itself we have told that one impedance triangle, voltage triangle. Have studied or not? Remember kartola. So based on this diagram or equations only, we have derived this AB and BC here. We have derived AB and BC here. So, and one more formula I will ask you here now. Cos 90 minus theta. Cos 90 minus theta. What is the answer?
Sin theta.
Sin theta. And sin 90 minus theta equal to?
Cos theta.
So in this minus theta place, I am going to use this one as minus delta plus. I will take outside here now. Here minus I will take outside here now. It is like sine minus delta plus alpha only. So you can write this one as cos delta plus alpha. So I naught cos delta plus alpha we have written here now. Where the cos 90 minus delta minus alpha is there. Again you write this one minus, you take outside, it will become plus here now. Sin 90 minus alpha plus delta, it is equal to sine delta plus alpha. Is it correct? Yes?
Yes, sir.
So this BC and AB we have derived here. So next what we will do, our aim is IP we have to calculate, the total primary current we have to calculate here. So here O to C, that is OC square equal to OA, this point up to here, plus this one here. Like this we are going to measure this one here, like this. The same triangle we are going to get here now. So OC square equal to OA plus AB whole square here now. This is only one term only up to here. This is one term only. So OA plus AB whole square plus this BC square we are going to use here. The impedance triangle, I think you have considered this one here now. ZRX. So in this one, Z square equal to R square plus X square. You have calculated, you have identified the equations. Almost all of you know that one. This impedance triangle का formula मालूम है ना सबको? R Z equal to square root of R square plus X square, impedance triangle.
Yes, sir.
R square plus square root of R square plus X square. Same formula based on this one only we are identifying here now. So OC equal to this OA plus AB whole square plus BC square. That one only we are writing here. So OC square equal to OA plus AB square, BC square here. What do you mean by OA? OA is nothing but NIS is there here. So NIS I will substitute here. Or IP, OC square, OC is nothing but how much it is? That is called IP is there. I will consider as IP square. And OA is nothing but NS. AB is nothing but that is I naught sine delta, that whole square we have used here now, whole square plus symbol plus is there. BC is nothing but this one I naught cos delta plus alpha, I naught cos delta plus alpha whole square we have used. So here this one you consider this one, it is A plus B whole square is there, the formula. This one NS plus I naught sine delta, that whole square is there. So A plus B whole square, what is the formula? A plus B whole square formula?
A square plus 2AB plus B square.
A square plus 2AB plus B square, yes. 2AB plus B square. So A is nothing but NIS here now, and B is nothing but I naught sine delta here. So N square I square we have written here now, and B square is nothing but I naught square sine square alpha plus delta plus 2NS I naught 2NIS I naught sine delta here. This is one complete here now. Here there is no A plus B and all. So I naught square cos square delta plus alpha we have considered here. So from this equation, see here N square I square I will write as it is here now, and 2NS I naught sine delta I will write as it is here now. So from this equation, see here, what we can take common here? Can you tell me? These two, only these two here only. I naught square sine square delta plus alpha plus I naught square cos square delta plus alpha. We can take I naught square outside here. I naught square we can take outside. Yes. So what is the left term here? Sine square delta plus alpha plus cos square delta plus alpha is nothing but sine square theta plus cos square theta. What is the answer? One only. So only I naught square into 1, that is called I naught square I have written here. Up to here, any doubts? Equation clear है, sine square delta plus alpha equal to cos square delta plus alpha equal to 1. So I naught square we have taken outside. I naught square into 1 is nothing but I naught square. Other things we have written, this written I have written, this I have written as it is here. Any doubts up to here? Yes. I'm asking to you people only.
No, sir.
Okay. Then what we have to do here, up to here, what we have calculated, IP square we have calculated here. Up to here, we have calculated IP square here. So IP equal to square root of N square IS square plus 2NS I naught sine delta plus alpha plus I naught square here. We have to do the square root here now. For the square root, we have consider 1 by 2. 1 by 2 we have used here. It indicates square root. Next, what is the CT transformation ratio equation? Transformation ratio. The primary phasor to the secondary phasor current. Magnitude of primary current to the primary phasor voltage. Primary current to the secondary current is the transmission ratio. Transformation ratio. Equation for the transformation ratio for the second current transformer. Primary current to the secondary current is there. I will show once again for the confirmation. Primary current to the secondary current for the CT is there. By using this formula, we have derived the equation for the IP only. But by substituting here, the transformation ratio are equal to IP by IS. In this place of IP, you substitute this whole thing here. I will substitute this whole thing here now, and divided by IS I will write. Divided by IS here. By doing this one here, now well-designed current transformer, I0 is less than, this I0 is less than NIS here. NIS is there. Usually I0 is less than 1% of IP here. This I0 is less than 1% of IP. So IP is therefore very nearly equal to the NIS. This primary current IP is there. It is very nearly equal to the NIS. We are going to call that one here now. For that reason, what we have to consider here now. So again, we will consider this same equation here, whatever the previous equation here now. N square IS plus 2NS I0 sine delta plus alpha plus I0 square sine square delta plus alpha 1 by 2 here. 1 by 2 we are going to consider. By doing this one, what we will do, we are going to neglect this term here now. So square root, you cancel this term, square. N square is nothing but N, IS square is nothing but I, and this I0 square is I, sine square is N plus this one. So because it is varying with N here now, for that reason, the IS, I0, sine delta, that is 1 by 2, we are making this one as negligible here now. This term, the product of these two currents, it is negligible, we are going to use here now. And then what will happen? So N, here NS is there, N into IS plus I0 sine delta plus alpha is there. So you separate this term here. NIS divided by IS, it is nothing but N only. IS gets cancelled, and I0 by IS into sine delta plus alpha. This is the transformation ratio equation for the current transformer here. The transformation ratio equation is N plus I0 IS sine delta plus alpha. This formula you have to remember here. The complete formula you have to remember here. This is the formula you have to remember. Okay. So what we will do next? This is the actually this much derivation is not there. If it is offline exam, it is useful. Otherwise, just for the equation you have to remember. Next, we will go for the error here. No, the phasor diagram, according to the phasor diagram, the tan theta equal to BC by OB we are going to consider here. BC is this one here now. BC by OB. OB is nothing but O to B here. Now it is nothing but OA plus AB we have to use. OA plus AB. Based on that, we have BC divided by OA plus AB we have considered. BC equal to I0 cos delta plus alpha, and OA equal to NIS, AB equal to I0 sine delta plus alpha. By doing this one, theta is very small, so we can write this one as theta equal to I0. Same equation we can write here now. NIS I0 sine delta plus alpha. In the radian we have written here now. So neglect the term here now. I0 sine delta term we are going to neglect, because when I0 is very small as compared to NIS, we can neglect this term. NIS ke saath it is very nearer is there. So one term only we are going to consider. So theta is approximately equal to I0 cos delta plus alpha divided by neglecting this one, only NIS is the term left here now. Based on this, we can consider cos A plus B. What is the formula? Cos A plus B. Anyone, can you tell?
Cos A cos B minus sinus A.
Same thing we have written here now. Cos delta plus alpha is there here now. A plus B we have considered here now. I0 we have kept as it is. cos A, cos B, cos delta, cos alpha, minus this I naught sin A, sin B we have used here, no, sin delta, sin alpha here, no. Approximately this sin alpha and cos alpha we have negligible here, no, as compared to this equation. Again, these two are negligible. So I naught cos delta minus I naught sin delta terms only we are using here, no. That is angle between the primary and secondary current here, no. Divided by NIS we will keep as it is here, no. The radian we have to convert into degree. What we have to do? Degree is 180 degree divided by 5, whatever the radian is there. By converting that, we'll convert into degree here, no. For the same equation, 180 divided by 5 we have done here. That is called, that is phase angle we have derived here. The phase angle we have derived here, no. Based on this, some errors are also there here, no. This theory part I will not explain directly. Errors of the current transformer, actually there are ratio error is there. Actually, the ratio error is the difference between nominal ratio and actual ratio to the actual ratio here. Is the ratio of nominal ratio to the difference between first nominal ratio minus actual ratio divided by actual ratio. What is the nominal ratio definition? Starting definition derive किया मालूम है क्या nominal ratio का? Yes or no? We have derived the nominal ratio already. Actual ratio is nothing but transformation ratio. This is R. Just now whatever we have derived this equation, same equation, whatever R is there, this one is the actual ratio, and nominal ratio is the magnitude of primary current to the secondary current here, no. That is called nominal ratio we have used here, no. Kn minus R divided by R is the percentage of ratio error. We can calculate how much error it is going to get, and the phase angle error, same equation we are going to use here, no. That is called Im minus IE here, no. The meter reading minus external current into cos delta sin delta divided by NIS here. That will give the phase angle error and ratio error. So it completes the current transformer. In the next class, we are going to discuss the potential transformer here. So only one term is left, that is called potential transformer. If potential transformer is over, then this chapter will complete. So here also again the phasor diagrams are there, equations are there. You have to, this is a little bit difficult potential transformer as compared to the current transformer. If the offline exam was there, you have to derive, this is the fixed question, derivation and a fixed question tha. But now in the online exam, you are exempting, they are not asking the derivation to derive, you peoples. So you have any doubts? The current transformers? Any doubts? Any doubts? Yes or no?
No, sir.
So I will take the attendance once again. Just a minute. 1, 2, 3, 4, 5, 6, 9. Roll number 9. 11, 12, 13, 14, 15. Roll number 16. 17, 18, 19, 20. 21. 26, 27. 32, 33. 38. Number 40. Rohit Jadhav. Rohit. Rohit Jadhav, are you there? Joined, not yet joined the audio. Okay, we'll stop here only and we'll continue in the next class. So we'll start the potential transformer. Hardly tomorrow your 4th unit will be complete, and 5th and 6th unit, it will not take much time. Remember that one.